Hi, welcome back to the course on Introduction to Machine Learning in Julia. In this lecture, we will continue to learn about various functions, conditional statements, sets, dictionaries, etc. in Julia. So coding will be very basic, but this will be very important and this will help you tremendously when you are in the later part of the course coding more complex things in Julia. So let's open terminal. And we have been, so here let me exit first. I have already got a Jupyter notebook open in terminal, but I want to start from scratch. Okay, so here is my terminal. So this is how how your terminal will look like if you are using MacBook. So here you can type Jupyter notebook to open Jupyter notebook. And this should open as a local host here. So now, once Jupyter Notebook is open, if you have not defined your terminal, your kernel as Julia, it might by default be Python, but you have to define it, the kernel to be in Julia. You can do that. So here I would like to open Jupyter Lab. Let me open Jupyter Lab. And here I can define the notebook. So firstly, Julia 1.1.1, and here the kernel is already Julia. If not, you click here and change the kernel to, if it is Python, change it to Julia 1.11.1, depending on which version you are using. Now I can click this notebook to just open this notebook instead of having the Jupyter Lab. So let me just open the notebook instead of the Jupyter Lab, and here I'll rename this as, this is not IPy notebook. This is just this is a Jupyter Lab notebook. So I will rename this as Learning Julia. Okay. So first things are some conditional statements. We can think of that. We have already, learned about this a little bit in the last lecture, but we'll continue to learn a bit more complex conditional statements compared to what we learned in the last lecture. So let's say x equal to 3, and now we want to print depending on the value of the x, whether the x itself is positive, negative, or 0. So we can write a conditional statement like if x greater than 0, print ln. And here we know that if we put a dollar symbol, it means it will print the actual value of x is greater than 0. Hence, x is positive. So we know that $x means it will print the variable value of x instead of x. So here it will just print directly x. Then else if x less than 0, print ln. I'll copy this. X is less than 0, hence x is negative. Fairly simple. And the last one, else. Here I don't have to put a condition, print ln. X equals 0. Now we can run this. Okay, we need an end statement. 3 is greater than 0, hence x is positive. That is what we are printing in the if statement. So here if is true because x is greater than 0. Now let's say x is -2, -3. -3 is less than 0, hence x is negative. So now else if condition is invoked. And if x is 0, then the last condition is true. So this statement will be printed. So this is a normal if else if statement. We can also write this in a bit more concise manner. So for example, let's say x equal to 3. If x greater than 0, then print ln. So this is like a conditional statement where if the condition is true, first part will be printed. Else, we will look for this condition is x less than 0. So I'm copy pasting x less than 0 here. So it's a cascading, right? X less than 0. If that is correct, then this will be printed. Otherwise, the last statement will be printed. X equals 0 will be printed. So now we can run this. Space required after. Yeah. Yeah, you see, so now whatever we wrote in this if else statement is also written, exactly same thing is being implemented here. So if this is -2, -3, then the second condition is true. If this is 0, so maybe I can, I don't know if I add a new line, if this will cause syntax issue. Yeah, I think there is a syntax. But I hope you can see the whole line of code. Basically, the first statement, this is the true part of the first statement. If the first condition is false, then it goes here. But the second part itself has another condition in which you are checking if x is less than 0. If that is true, this is printed. If x is greater than 0 and less than 0 are not true, then this is printed. So if x is 0, it will go to the last condition and print x equals 0. So whatever we are accomplishing in this if else statement, we are also accomplishing the same thing in this one line of code. But I prefer this because this is much more readable. The readability of this is much poor, as you can already see. Okay, so these are the conditional statements. Now let's look at for loops. So for loop is fairly straightforward. Let's say x equal to 5 for I in 1 to x. Print ln. This is iteration number. And then to print the number as a variable, put $symbol and then put I. So, oh, end statement, I forgot. So now it's printing, this is iteration number. So it's going 5 iterations. The value of x is 5. If we change this to 15, it will print all the way till 15. So here I runs from 1 to 15. What if we make this from -1 to 15? Then it will start from -1 because iteration number is -1, 0, 1, 2, etc. So here I takes the value -1 to 15. This is again fairly straightforward, nothing too fancy. This is exactly how you run for loops in Julia. Very similar to how you do it in Python. Now let's check while loops. So x equal to 10 while, let's say x greater than 0, print ln. The value of x is x, then we can say x minus minus. So here we will reduce the value of x by 1 in each loop. And as long as this condition is true, it will keep on running. And x minus minus is invalid operator, x minus equal to x minus equal to 1. Okay. X minus minus is not a valid statement, valid syntax. So here initially the value of x is 10. So then this is executed, right? Because while x greater than 0 condition is true. So this is executed. Then the value of x reduces by 1 to 9. Like that is executed until the value of x becomes 0. So that this is the while loop. So while loop is executed until the statement becomes false. So if this was not there, the while loop will keep on executing because x greater than 0 is true always. So then this will crash. So while loop can go into infinite loops if we are not making sure that the condition becomes false at some point. All right, so this is again fine. Now let's go into the next part. Now we can define a function. So let's say function addition. I'm calling the function as addition, and then it has two inputs A and B. Output equal to A plus B. So this function adds two numbers, and we can return output. Now let's say we are calling the function println function of 3,5 unexpected. So I guess addition of 3,5. You need an end statement. Yeah, end statement I'm constantly missing to add. But here the function is called, function name is addition. Addition is called with these two as the parameters, as the arguments 3 and 5, and output is A plus B. We can define any function like this, multiplication. I mean, of course, you don't need a function to do this, but I'm just showing you how to define functions. So here, if you call multiplication instead of addition, the output will be 15, as you can see here. This is exactly how you call functions. Now, you can also call functions in a recursive manner. So let's say multiplication of, so let's say you want to multiply whatever is the output of adding two numbers with another number. So let's say addition of, so I first want to add 1 and 4, and then to whatever is the output of that, I want to multiply that with 5. So here the answer should be 5 multiplied by 5, 25. So if I run this, answer is 25. So here we are calling the function within a function. So firstly, the argument into the multiplication function is whatever is the output of this function's processes. So addition function is called with these two as the arguments. So the output of that is 5, and input to the multiplication is output of this and 5. Now if we change this to 6, the output will become 5 multiplied by 6, which is 30, as you can see here. So this is how you define function. Very simple. The syntax is very straightforward. You can run this as I'm running the code, and you'll find it very straightforward to implement. You can also define function in one line. For example, square of x equal to x square, and you can print ln square of 5. This should be 25. So here you are not writing like function with an end statement and a return. You are just defining the function called square in simply one line. You could also do the same thing by writing like this, square of x output, or you can write return x square and with an end statement. This also you can do. So if you hide this, this also provides the output as 25, but you can accomplish the same thing by just this one line. And instead of square, you can also say cube of x, and then this is x cube. So this will be 125. Okay, cube of x. Yeah, 125. So this is how you define functions in one line. So if you only need a small, like you don't need to, you don't want to spend this much space in defining the function, you can simply define the function in one line. So this is definition of functions in Julia. There is one more thing called anonymous functions. So here the function has a name. The name of the function is called cube. Here the name of the function is called addition. Here the name of the function is called multiplication. In Julia, you can also define functions without any name, and those are called anonymous functions. So here the input is x, and such that you are creating x square as the output. And here into this function, the argument you can pass whatever you want. So here, so you're passing 6 as the argument. The variable is x, where the argument's value is attributed to, and the operation that is being done is x square. So here, if you run this, you will get the square of 6 as the output. You can do whatever you want here. So let's say y square Then here you can say x comma y and 6 comma 2. So that will be 36 plus. I think uh, I have to do something in the syntax here. I'm not sure. I'll try to treat it as a callable object. Okay, now it's working. So I don't think this bracket is needed, right? Yeah, only I just need this bracket. So x comma y. So I have two arguments and I'm passing the value of x and y here. And the operation that is being done is x square plus y square. So 36 plus 4, 40. If I keep this as y, output will become 38. If this is 6y, the output will be 36 plus 12, 48, like that. So see here, I did not put 6 multiplied by y. I just put 6y. So Julia identifies that 6y is basically 6 multiplied by y. So it could be 2x plus 6y, which is 12 plus 12, 24. So this is how you define anonymous function. So here also it's a function with arguments, but the function has no name. So that's the reason why it's called anonymous functions. Okay, so that is done. Now, one more thing is the scope of the function. So let's say I am defining a function like this. Function variable scope. I just want to show you that the scope of a variable that is defined inside a function is basically within the function only, not outside of it. So here I can say a variable scope x. Then here we can say y equal to 2 and return x plus y. So here y is defined inside the function, but x is whatever value we are passing into the function. And let's end, then print ln. So here if we try to print y, it should show error because y is not accessible, right? But if we try to print variable scope of 3, then it should be x is 3, y is 2, so 3 plus 2. The answer should be 5, what is printed. So here you can see that since y is defined inside the function, its scope is limited within the function. You cannot access the value of y, access the variable y from outside the function. So this is about the scope of variables when you define variables in Julia. Now let us look at array and tuples. So array 1 equal to 1, 2, 3, 4, 5. We have already seen this a bit in the last lecture, but I just want to recap it a little bit. So here, if we are printing array 1, it will be a vector of int 64. But even if one of this is like a float, it will change that this is float. But and all the other numbers will also become float. But if all of them are integers, it will remain as integer. So this is array. Now we can do operations like pull and pop. So pull, if we are pulling, let's say, a number into the array, let's say we want to pull 6 into this array. It's actually not pull, it's push 6. Then the array size will increase. The array 1, now it's printing as 1, 2, 3, 4, 5, 6. But what if we are pushing 3? Then it will, so 6 was already added before. That's the reason why it increased in size, because we did not redefine the array. At the moment, this array 1 has 5 plus 2, 7 elements, because the 6th and 7th elements are 6 and 3. So now if we run this again, so let's say we run this in a for loop for I in 1 to 5. So this will be running 5 times, push this and end. Now what should happen is push the value of I, and let's say array 1 equal to, I don't know if empty array can be defined like this. Let's see. And we can print ln of array 1. So now it's okay. So if this is 0, then it should be 0, 1, 2, 3, 4, 5. So initially array 1 had a number 0. Then in each iteration of this for loop, we are pushing I, the value of I. So I runs from 1 to 5. So 1, 2, 3, 4, 5 gets pushed into the array. There is one more operation called, so if what happens if I run this again? So let's say I comment this. Now, if I run this again, what happens? Again, 1, 2, 3, 4, 5 will get added here because the definition of array 1 will not change. So array 1 right now is in this shape. So now 1, 2, 3, 4, 5 will get again added. If you want to see, here it is. See, it got added. So if I run this again and again and again, the size of array will keep on increasing, right? Okay. But let's come back. Now there is an operation called pop. So popping is nothing but not poop, sorry. Pop. So popping is removing an element from the array. So here, let me remove the loop, and what I will do is from array, I want to remove this number 2, which means this should be gone, right? Actually, pop array 1. Let me define array 1 equal to 1, 2, 3, 4, 5. Let me check what's wrong. Actually, in popping, we can only remove the last element. So if I run this, the last 5 will be gone. So it will be just 4. If I comment this and then run this, 4 will be gone. Now if I run 3 will be gone, 2 will be gone, 1 is gone. Now if I run, I don't know what happens. Okay, yeah, array must be non-empty. Makes sense. There is something called delete at, not delete at. And then here we can define the index of the element that we want to delete. So here we want to, let's say, delete 1. So to remove confusion, I will randomly put some other number. So I want to now remove the element at index 1. So index starts from 1 here. So now if I print that 10 won't be there, 12, 15, 53, etc. will be there. What if we want to delete 4th element? Then just put this. And what if the index does not exist? 14th element does not exist. Then attempt to access 5 element at index 14. 5 element vector at index 14. So that is the error. So here 5 also can be removed. So this is delete at. You can delete an element at a particular index. So these are arrays. There is one more thing called tuples. So tuple are like immutable variables. So tuple equal to, it's in normal bracket. Let's say 1, 2, 3, 4, 5. So now if you print type of, you can print the type of tuple, and it should show that it's tuple. Here on the other hand, if you type of array 1, you can see that it's vector in 64. And here it's in 64 it's showing, but if I change this to 1.0, probably it should change to variable float 64 variable argument. Okay, what if this is a float? Then this should become, okay, so in tuple, it's showing everything, right? So it's showing that first element is float, second is string, integer, integer, integer. Now this can be a character. So this became a char. Now 4 can stay as an integer, and maybe this I can delete, not needed. So this is tuple. Now what if we try pull, or let's say push, not pull, push something into the tuple, push. I'll rename this as tuple 1, comma, let's say I'm trying to push the value 5 into the tuple. It should show an error because check for spelling. Push. You have to add this this character. So basically, tuples are immutable. You cannot change the values in a tuple once defined. So that's why the error is coming. We could try something else though. We could create a tuple of similar name. For example, tuple 1 equal to tuple 1 comma 5. So now I hope the new value will be added. Actually not, because here you're creating a new tuple with first element being tuple 1 and second element being 5. But if you try push and pop, it should not work. Push of tuple 1 comma 5, this should not allow you to push. If you're trying to pop something out of the tuple, that also should not work, because that is because of the immutable property. But basically in tuple you can add multiple type of elements. You can have float, string, character, etc. in one single tuple. However, if in the array you try to do that, this should it also works, but let me remove this. So if this is the array, then basically it's a vector. Okay, in array also it's possible. You can have any different kind of element within the array. Oh yeah, character means it should be only one. Yeah. Type of array, alias for array. Yeah, this is array containing any kind of because you have mixed character, integer, string, etc. So then array is showing vector of any. Whereas if it is just integer, it should show int64. And if one of them is converted to float, the whole array is converted to float. So these are arrays and tuples in Julia. Next is dictionary. So let's say dictionary, let's say I define a dictionary named student, and name is associated with my name, maybe first name, and last name cannot just juxtapose string literal. It's because I think dict is not defined in the main. Let me check. This should be capital. Okay. So here you have dictionary mapping from string to string, two entries. Last name is the key, corresponding value is Panat. First name is another key, corresponding value is Sridat. You can also add a string mapping to, I don't know if integer can be mapped to a string. Let's see, 1. Then, okay, that is also possible. So here you can see that since all the values, so this is called key, this is value, all the values are strings. You can see that here it's string. So dictionary of any mapping with string. Why is this any? Because this key is string, this key is string, but this key is 1. It's integer. So that's why here it's showing any. And here you are printing everything. So and you can also create a mapping from a character into a string or number. This is also possible. Then this will also become any, because now in the key you have string, integer, character. In the value you have string, integer. So that's why you have any and any. So this is about dictionaries. We can also try printing some specific characters in the dictionary. So if we write println student of first name. So here you can notice that here, if this was an array, we'll put the index, but here you're putting the key, the actual value of the key. So key is first name. So let's say this is student 1 and ID is some ID number. I'll put this as an integer and that's it. So this is student 1 and I can replicate student 2. Yeah. And ID is 4. First name is, let's say, Arun Krishnadas, something like that. So ID is this. So we have student 1 and student 2. And if we are printing the first name of student 1, Sridhar should get printed. And if we are printing the first name of student 2, Arun should get printed. Then same goes with ID. So if we are printing ID of the first student, then ID of the first student is 122323. Second is 122324. So these are dictionaries in Julia where you can store key value pairs. Now, the final thing that we will cover in this lecture is set in Julia. So let me first comment this. So let's define set 1 and set 2. So this is 1, 2, 3, set 1, 3, 4, 5, set 2. And we can define certain operations just like how you define operations in actual sets. So in the union operation, the two sets will combine. So it will become a set called 1, 2, 3, 4, 5, 1, 2, 3. And yeah, 1, 2, 3, 4, 5. Let's run the code. 5, 4, 2, 3, 1. I guess I don't know why is it printing like that. 5, 4, 2, 3, 1. Then intersection will be simply 3 because 3 is the only number that is common. Then set difference is the difference between these two sets is since 3 is the only common, 1, 2, 4, 5 should be the 3 is common, 2 and 1. Difference between set 1 and set 2. Here it has 1, 2, 3. Here it has 3, 4, 5. Okay, so I guess in difference, yeah. So whatever is there in set 1 minus the intersection between set 1 and set 2, I guess. So that is why it's 2, 1. So if this was set 2 and set 1, then the output should be 4, 5. 5, 4. Yeah. Okay. So this is set operation. I don't think set operation is that commonly used. I have never used this in, at least in the machine learning context in Julia, but some basic things which is good to know. So that's all about basic operations in Julia. Now we are fully ready to enter into more complex programming. We can enter into data science. But before that, in the next lecture, I'll cover something very, very interesting called Pluto notebooks. So Jupyter notebooks is something primarily for Python. Now it also has Julia, but Julia has its own notebook called as Pluto notebook. It's an amazing thing. I had used it very, very extensively in a couple of years ago, and it has so many features, so many interactive widgets. We had even deployed websites which were built using Pluto notebooks. So I will cover in the next lecture how you can work with Pluto notebooks and what kind of cool things you can build and show to people using Pluto notebooks. So please take care until then. Thank you so much. If you have reached this far, I really want to congratulate you because you have come a long way in terms of learning the basics of Julia. Now we are entering into a bit more complex things. Pluto notebook will be one more layer complex than these typical simple conditional statements, variable definition, scope of variable, etc. These are basic things that we have been doing so far. Pluto notebook will be one more layer deeper. And as we enter into deep learning, data science, machine learning, and deep learning in the following lectures, the lectures will become a bit more intense. So I really highly recommend you to follow with me along with these lectures, code along with me. So as you're watching the video, keep a Jupyter notebook open on the side or whatever your preference is, Visual Studio Code or anything it may be, and then work with me. So congrats on being diligent so far. Congrats for finishing the course so far, and I look forward to seeing you again in the next lecture. Take care until then, and bye.